Now I would like to introduce another famous member of our club, Captain H.J. Round. His remarks were recorded on the occasion of our presentation of the Armstrong Medal to him in 1952. May I present Captain Round?
In the year 1897, it's a pretty good long time ago, I was still at my local grammar school in Cheltenham in England. Like most grammar schools, we were frequently visited by special lecturers. And one afternoon, one of these special men came down to tell us the story of Hertz, and quite incidentally about a young Italian named Marconi. He gave us a demonstration of ringing a bell over the length of the hall. Although very interested in science, I didn't get up any interest in this new idea and scarcely remembered reading anything about Marconi and his work during the next 4 years. From 1898 to 1902, I spent the usual time at college, filling my head with the usual things and passing the usual examinations. But during my last year, scholarship funds ran short, and I did a bit of tutoring to a young blood, a lot of money, who had bought himself a complete spark coil and coherer arrangement. So I taught him a bit of calculus, and he showed me how wireless worked. Still, however, only over the length of the room. Education now finished, I was thrown on the cold world to look for a job. And I came across an offer by Marconi's Wireless Telegraph Company in the English Electrician to take young students on for training and trial at 10 shillings a week and all found. I duly applied for the trial job, and after having been told that I had a lot to forget, I was taken on. And I accepted a job to go to the United States and join Marconi's Wireless Telegraph Company of America, a company recently formed. I landed here in New York in the fall of 1902, and I stopped in America until 1908, when I returned permanently to England, rather regretfully and thoroughly Americanized even to my speech. That period, 1902 to 1908, would require a great dramatist to tell the tale properly, and I can only give you a few rather disconnected stories of the happenings of those years. Firstly, I was sent to Babylon, and there I learned to operate in Morse and continental Morse, and in the end I spoke neither language as well as a second-class ham. Ships passed us daily fitted with Marconi's wireless, and it was our job to communicate with them. Our apparatus for communication was housed in that little hut some of you may have seen at Riverhead, which I identified and Major Armstrong rescued from a field in Babylon in 1929. The transmitter was a spark coil, a capacity of 0.015 in Leighton jars, a jigger, which was our word for a high-frequency transformer, and a telegraph key. The receiver was the back box that contained the coherer, tapper, relay, and a host of condensers and shunts. And outside there was a tape recorder. You can hardly imagine how helpless one felt with just that black box, with its impersonal tapper rattle as the only connection between you and the outside mysterious world. There was no adjustment for signals of different strength. And of course, the only criterion of different strengths was the fact that the tapper and the relay had to be readjusted. And not many ever really acquired the art. I talked with Marconi in after years as to how that complicated coherer tapper relay Inca system came about. And he definitely told me it was the rigid requirement of government telegraph services for recorded messages that forced him to it, but he was always trying to get away from it to a more reasonable practice. And it was not very long before he introduced the magnetic detector. That detector, while perhaps not quite up to some electrolytic and crystal types in sensitivity, was the limit in utter reliability and revolutionized the previous erratic services. It remained, for short distance work, the standard receiver right up to amplifying days. In the world outside, I mean outside the Marconi service, one by one there arrived the Fleming valve, although that was rather connected with Marconi, various electrolytic detectors. I think there were in general two types, one invented by Fessen and one by the Germans. One was a bit of wire sticking out and the other was a hole. And then a spate of crystals. Only one of these crystals was really worthy to be a commercial article, and that was carborundum. All the others, while being excellent in experimenters' hands, and I expect many of your hammers have used them, failed the rigid requirements of a transmit-receive service and those terrors of the ether, atmospherics. All these detectors depended on the telephone receiver, but this seemed at once to give you a real communion with the surrounding space. Of course, in reality, the gain was that the ear was being used to the full extent to measure strength, quality, types of signals, and even to permit mental separation of superimposed signals. All operations the coherer couldn't perform. For a long time, officials demanded the tape records, but finally they had to give up the struggle. I remember on one famous occasion, we took a large number of messages from a ship, and the ink had broken down, and we read the signals off the tapper, wrote the messages and sent them off. And we nearly all got the sack for doing it, although we collected a good deal of money with the telegrams. Past our Babylon station came the Atlantic liners, fitted more and more in numbers with Marconi gear. But in those earliest days, it was very fortunate for us that we seldom had messages for them. The traffic was all the other way. How many of those operators could really operate a coherer set, I don't know, but it was very seldom they could read more than just OK, RD. So that's that for the mere bread and butter operating. What about the engineer's job, where the technical romance should be? At Babylon, we didn't get much romance. I believe I was immortalized for a long time with the round ground. And in later years, I had quite a fan mail about it. But really all my connection with it was to dig the damn trenches under orders, put the zinc sheets in them and solder up the necessary wires with a blowtorch. And if you have ever tried soldering dirty zinc on a cold windy day with a blowtorch in the open, you would probably agree with my immortalization. The fact that the trench was circular and fitted my name, I must assure you, was quite an accident. In 1903 and 4, in my spare time, I investigated the use of dust cores, the suggestion which I obtained from a German scientific report. I obtained finely divided iron from a New York chemist somewhere in 3rd or 4th Avenue, I remember. I got this iron by hydrogen. They sold for used in medical purposes, I believe. And I molded it into shape with paraffin wax. Not much technical information was obtained, but we found that we could use them for tuning both receiver and transmitter. Actually, the knowledge gained for immediate use was nil, but later on, in the First Great War, the knowledge was invaluable. I made up quite a large number of these coils. The core was usually shaped when warm by rolling it between one's hands, the shape being rather ellipsoidal. The wire was then wound on top. Or if it was a variable thing, there was no wire on it. I'd left Babylon for some time, and one day I met a Marconi engineer, E.J. Watts by name, who apparently had been sent to Babylon to clear up any mess I had left. My golly, said he, what did you do with all that filth you left in that room of yours? Most of it wound with coils of wire. We had to buy a gallon of carbolic acid to disinfect it before we buried it. For a moment I was puzzled, and then it occurred to me that the iron powder had rusted over the surface of the paraffin-loaded shapes, giving to a disordered imagination a sinister appearance to the ellipsoids. Among other experiments, with some transmission tests between Babylon, Sagaponack, and Saskatchewan. These were done in spare moments, which gave me some very valuable information about land and sea transmission with different frequencies. By the way, I got here the actual articles that I published later on those tests in the Electrical World, I think it is, the New York World. They've got for me photostats of them. This, again, was of no immediate value, but later on was of immense value to me during an expedition up the Amazon in 1910. Frame aerials, cosine and cardioid diagrams were investigated, although sometimes more was expected from them than should have been. I hadn't got a very clear idea in my head that I couldn't get more radiation from a small frame and a small spiral. I thought I could get more than I could get from a big aerial. I know. Rather a dream, but anyhow, we got the diagrams. There was a curious sequel to these directional experiments. When Marconi announced his directional aerial work with horizontal aerials, I saw the resemblance his results had to my frame aerial combinations, which were combinations usually of a frame and a vertical antenna. I was with the New York Telephone Company. And being for a short time free to do so, I wrote an article in the Electrical World analyzing Marconi's results. Some little time afterwards, Bellini and Tosi announced their directional aerial system for direction finding. During the First Great War, I used the Bellini-Tosi direction finder aerial system greatly and, of course, published my work. Incidentally, the Marconi Company were licensed under the Bellini-Tosi patent, so there was no cribbing there. I met Bellini shortly after the war, and he told me that he'd invented his system after reading that original paper of mine in the Electrical World, when I show how a frame and a vertical aerial could give a cardioid diagram. He merely did a similar thing with two frame aerials at right angles and arranged to get a cosine diagram shiftable merely by rotating a coupling coil. So that again, the playing about at Babylon brought a dividend. Towards 1906, the picture began to change for me. Marconi's ran short of money, and I was asked to find myself another job, at least for a time. I went down, interviewed Edison. I asked him to take me on, but he'd only offer me $12 a week, and I didn't quite see how I could live on that. Finally, I landed up in the New York Telephone Company's laboratories in Cortlandt Street, where I spent a very instructive year, during which I carried out many experiments at night time after my telephone work was done, down in the Marconi Works at Front Street. The Marconi Company said I could still go on working down there as long as I didn't want any money. There my first wireless telephone was born, and many of the night I was on the air with an occasional ship's operator hearing me. I don't know whether anybody ever remembers that Front Street place, but I used to stop there all night in fear and trembling with rats around everywhere, their little pink eyes coming round when I was sleeping on 2 or 3 coil boxes laid out. It was too cold very often to come out and go home. All good things come to an end. 3 junior engineers of the New York Telephone Company, one of whom was me, had their office in the Dye Street annex. There were many tenants in that building other than the telephone people, and so we didn't worry much about the old man in the office next to us, who was continually complaining about the noise we made, the natural noise of enthusiastic youth. One fine day, the great amalgamation of AT&T, a New York Telephone Company, and the Western Electric was announced, with Theodore N. Vail as president. Theodore N. Vail was the old man next door. Fortunately for me, Marconi's now had enough in the kitty to take me on again. Else I might have been out of work for a long time. I don't know how the other chaps fared. I never found out. My stay in America was gradually coming to an end, but during the last period, I established a receiving station at the top of the Times building, primarily to receive the messages to the Times relayed by Glace Bay from England. A weekly summary of European news was sent from England to Glace Bay via Clifton. And previously to this Times building stunt, it had been sent on from Glace Bay by the ordinary telegraph. I made use of that tower for furthering my telephone tests at Front Street. We did telephony over New York for quite a time between those, pretty poverty-stricken telephony. I mean, it was an old arc with a curious system of modulation, and the wavelength used to shift on its own. You didn't know where to find it on the receiver, but anyhow, it was telephony. We did a final stunt at that Times building by giving direct reporting of a motor car race upstate, minute by minute, on bulletin boards in Broadway. I went upstate, took an old 10-inch spark coil, found a suitable hotel with a water tower overlooking this race course, pushed an aerial up. I went, put the aerial up myself. I was scared stiff climbing up that water tower because it was on the top of a hill as well. We got this aerial up, and I shoved the coil on AC, the mains AC. I don't know whether I left the brake in or not. I forgot. But anyhow, it was plain aerial I sent. And the signals were excellent in Tyres building. A little bit of tuning to keep my friends DeForest out. My time had come, and I was sent for by the English Marconi Company. I left behind a good many friends. Back in England, I was posted down to the factory, which had been shifted from Chelmsford. The English Marconi Company I found rather weak financially, but I had been used to being paid in bits in the United States, so it didn't matter to me. Their low water at the time was attributed by some people to the fact that they had moved from Chelmsford and their luck had gone. So back they went to the old town, and I must say things began to look up then. At Chelmsford, I erected my wireless telephone with an arc and a carver under detector. Both, you will note, pinched from other inventors. And Marconi came to see it working over a distance of about 5 miles. When I had Charlie Prince, who was a very charming young gentleman, I had him as my assistant. He was at the other end of this wireless telephone when Marconi came. We were at Broomfield, an annex to Chelmsford. And Prince stuttered. I picked up the telephone and asked him to talk a bit so Marconi could hear. Well, Prince started a thing from Shakespeare, I am no orator as Brutus is. But he got as far as orator, and this is what happened. I am no orator. And Marconi looked at me, he said, what's the matter with this apparition? This was my second sight of the great man, the first having been in Chicago. But this time my luck was in, and I dreamed of joining him personally. Somewhere about 1912, 1913, one of the major discoveries of the art was made by one of your members. I remember reading in a technical journal a short note about John L. Hogan's discovery of the crystal heterodyne. I was so intrigued that I promptly put up a circuit to receive Clifton. I was down at Chelmsford, but fitted it with the most insensitive detector that I could think of. With an adjustable arc, I arranged the heterodyne, this detector. Clifton was quite inaudible without the heterodyne, but came in loudly when the heterodyne was turned on and tuned. I then tried one more experiment. With a good crystal receiver on a certain aerial going up to the top of a mast, I could get very fair Clifton signals. But on lowering the aerial to half the height, the signals vanished. That was a very normal effect with the ordinary rectification. Then the heterodyne was turned on, and the signals reappeared, and then I could hold them until the aerial was lying on the ground. These tests satisfied me that I had now a detector which was linear down to 0 signals, a point of even greater importance in the later superheterodyne. Certainly the ticker would be linear, but its crudity left it in the background. That period, during which we were carrying out those direction-finding measurements on the positions of ships in the North Sea. When we started the art of direction finding with valves, with tubes, I should say, or what my wife calls them, bottles, we started with little knowledge of one particular error. That was the night error. It's practically cured, even on long waves now, by new methods. But at that time, we didn't know there was such a thing as night error, and we gaily took directions in the daytime and watched ships going, and then we went on giving reports at night of movements of stations, movements of ships, and all that. Well, the Admiralty were very secretive. They accepted all our reports, but didn't tell us anything and didn't tell us what the ships were, who they were. But one day I was up at the Admiralty talking to the captain who was in charge of, officially in charge of our stations at headquarters. And he said, who do you think that certain station is? He named the letters. I've forgotten them now. Named the letters. Who do you think it is? I said, I don't know. It seems to move pretty fast. It moves an awful lot every day. He said, yes, you take it out to sea about 80 miles in an hour every night, don't you? And I said, yes, we thought it was a Zeppelin or something like that, but it does move pretty fast. Why does he do it every night? He says, it's the island of Borkum. I don't know. So you see, we weren't always quite as accurate as Admiral Jackson said. We gradually learned, of course. The real trick was to learn when to reject the readings. When the slightest trace of night error was on, we just threw the readings aside and didn't report after that. Just before the war, when we were in the middle of digesting all the new knowledge, I heard that there was a young man in New York with a black box who was performing radio feats which sounded rather like what we were doing. I forgot about it until one day, in October 1917, there arrived in my laboratory in London, packed in uniform, a large American youth named Armstrong. As he had all the necessary credentials, I got into a huddle with him immediately, and I don't seem to have got out of it yet. His first move was to show me that he could beat me hands down by producing in quite a short period the superheterodyne. And of course, as you know, it was followed by one damn thing after another while we wicker fry were just plodding along. Although during the war, one was able to construct stable cascade amplifiers with such methods as I described in my direction-flying paper, they were not really economical solutions. We wanted to use the full power of the tube in each stage without running into trouble, particularly with shorter and shorter waves. Very soon after the war, I determined to solve the problem in another way. The difficulty, as you all know, was this. You connected an input circuit to a triode, and then you put on an output circuit. Now, the only connection between these circuits should be one way. That is through the valve action. But unfortunately, there is another connection which energy can flow backwards, and that is through the grid plate capacity, which is comparatively large. Broadcasting soon brought out a demand for some solution of the difficulty. The better the valve, the more trouble we had. Solutions of this problem were given by neutralizing methods, which we actually used in some of my earliest valve circuits, but which were brought to perfection by my friend, Professor Hazeltine. I determined in 1919 to see if it was not possible to make a valve in which that capacity connection was missing. And I got made up some 4 electrode valves, very like those small valves you had passed round. They had one more pip on the side, as I wished also to maintain the small shunt capacity. There were, however, 2 grids, the first one being the usual control, and the second one a finer meshed one, which I called the screening grid. With a number of these tubes, I immediately built up a most wonderfully stable amplifier with 3 and 4 stages of amplification. Of course, I immediately approached the patent authorities, who at once dashed all my hopes to the ground by showing me a patent by the German Schottky, dated 1916, with exactly the same device. I've deliberately left out, in this account, the revolution caused by Marconi with the shortwave beams. But Major Armstrong has so very thoroughly treated this in his Edison medal paper. And as I supplied him with most of this information, I thought it unnecessary to bring it up again. I thank you, gentlemen, for your kindness.